Welcome back, students. Today we'll be introducing a new topic in our study that is called projectile. Projectile motion is a very important topic from the examination point of view, so it is very important for you all to go through this topic properly and understand every single step so that it becomes convenient for you to understand what is a projectile, since you have observed this type of motion quite often. The terminology might be new, but once we start dealing with the topic, you will find that most of these things you have observed in your day-to-day life. So primarily we'll be understanding what is a projectile, we'll be going through a couple of examples, and basically we'll be deriving some very important formula. So we'll begin with a very basic question: what is a projectile? Projectile is the name given to a body thrown with some initial velocity with the horizontal direction and then allowed to move under the action of gravity alone without being propelled by any engine or fuel. The path followed by a projectile is called its trajectory. On the screen you can see some examples of projectile. Some common examples of projectile are a body dropped from the window of a moving train, a bomb released from an aeroplane in flight, a bullet fired from a rifle, a piece of stone thrown in any direction, a javelin or hammer thrown by an athlete, a jet of water issuing from a hole near the bottom of water tank. In all these examples, we find that a projectile moves under the combined effect of two velocities. Number one, a uniform velocity in the horizontal direction, which would not change provided there is no air resistance. Second, a uniformly changing velocity, that is increasing or decreasing in the vertical direction due to gravity. These two perpendicular velocities have no effect on each other. Hence, while studying the motion of a projectile, we shall consider there is no frictional resistance of air. The effect due to rotation of earth and curvature of the earth is negligible. The acceleration due to gravity is constant in magnitude and direction at all points of the motion of projectile. So, applying these assumptions, we shall begin with the study of projectile given horizontal projection. For that, you need to refer to the picture. Let us consider OX, a horizontal line parallel to ground, and OY is a vertical line perpendicular to the ground. Suppose an object be projected from the point O above the ground with velocity u horizontally, that is along OX, such that x0 is equal to 0 and y0 is equal to 0 at t equal to 0. Soon after projection, the object will move under the combined effect of two independent perpendicular velocities. Number one, the horizontal velocity u, which remains constant throughout the motion, as we are neglecting the air friction. Second, the vertical velocity, which increases due to gravity. Initial value of this velocity at O is 0. During the motion, the object covers horizontal distance due to horizontal velocity and vertical downward distance due to vertical velocity. So first of all, we will find path of the projectile. Let's go back to the picture. Suppose at any time t, the object reaches at P. Now P is having a coordinate x, y, as you can see in the picture. Clearly, x is the distance traveled by the object in the horizontal direction in time t, and y is the distance traveled in vertical direction in time t. Now, for motion along the horizontal direction OX, since the velocity of object in the horizontal direction is constant, so the acceleration, if we assume that the acceleration is AX along horizontal direction, that will be equal to 0. The position of the object at any time t along the horizontal direction, that is along x-axis, is given by x equal to x0 plus uxt plus half axt square. Now x0 is equal to 0, ux is equal to u, and ax is equal to 0. Now we have to substitute these values in this equation, so we will get, therefore, x equal to 0 plus ut plus half into 0 into t square. That gives us x equal to ut. Therefore, t will be equal to x divided by u. Mark this as equation number 1. Now, motion along the vertical direction OY. Here, y-axis is taken downwards. Let us go back to the figure again so that it becomes clear to you. Here, y-axis is taken downwards, since the downward direction will be regarded as positive direction. Since the vertical velocity of object is increasing downwards due to gravity, hence the acceleration of the object, that is ay along vertical downward direction will be equal to plus g. Again, the position of the object at any time t along vertical direction, that is along y-axis, is given by y equal to y0 plus uyt plus half ayt square. Here y0 is equal to 0, uy is equal to 0, and ay is equal to plus g. So putting these values in the above equation, we get y equal to 0 plus 0 into t plus half gt square. Therefore, y is equal to half gt square. Now, just remember what is the value of t. From equation 1, we know that t is equal to x by u. Let us substitute this value as t is equal to x by u. Therefore, y is equal to half g x by u square. That gives us y equal to half g by u square times x square. Now if the bracketed term, if you look into the bracketed term, all the terms included inside the bracket are constants, half g by u square. So we can replace this with a constant k and then write down x square, where k is equal to half g by u square. It is a constant. Now this equation is an equation of a parabola which is symmetrical about y-axis. Hence we can write down path of projectile projected horizontally from a certain height from ground is a parabolic path. Next we shall find out the time of flight. What is time of flight? It is the total time for which the projectile is in flight. That is the time taken by object to go from O to C. Let us go back to the figure. The time taken by the projectile to go from O to C. Let it be denoted by t. If h is the vertical height of point of projection O from C, taking vertical downward motion of object from O to C, that is along OY direction, we have y0 equal to 0. The height we have just now assumed as h. uy is equal to 0, ay is equal to g, and for time we have assumed it as t. So again we can write down with these assumptions as y is equal to y0 plus uyt plus half ayt square. So we can write down h equal to 0 plus 0 into t plus half g t square. That gives us t to be equal to root over 2h by g. So this is the expression for time of flight. Horizontal range. It is the horizontal distance traveled by the projectile during the flight. That is the horizontal distance covered by the object while going from O to C. So if we denote it with R, taking horizontal motion of object from O to C, that is motion of the object along OX direction. We'll be considering motion of the object. Let us again go back to the slide having the diagram. So you can see we are considering the horizontal motion of the object from O to C, that is motion of the object along OX direction. Motion of the object along OX direction. Okay. Let us come back. So now we can write down x0 equal to 0, x, that is the range, it will be denoted by R, ux is equal to u, and ax is equal to 0. So now small t, that is the time of flight, that is equal to root over 2h by g. So writing down the equation as x is equal to x0 plus ux t plus half ax t square. So we can write down therefore r equal to 0 plus u times root over 2h by g plus half into 0 into t square. So that gives us r to be equal to u into root over 2h by g. Velocity of the object at any instant. At the instant t, the object possesses two perpendicular velocities. The horizontal velocity, if we denote it by Vx, that is equal to u, and which can be obtained from the relation, and the vertical velocity, obviously vertical velocity Vy. So this can be obtained using the relation Vy equal to uy plus ayt. Now we know that uy is equal to 0, ay is equal to g. Therefore Vy will be equal to 0 plus gt, which implies Vy is equal to g into t. The resultant velocity v will be equal to root over vx square plus vy square, that is equal to root over u square plus g square t square. If v vector makes an angle beta with the horizontal, then we may write down tan of beta equal to Vy by Vx, that is equal to Gt by U. So we will get beta equal to tan inverse Gt by U.